Uh, Good evening, everyone. So today we are very delighted to have this online industrial expert talk on pattern matching and anomaly detection. So last week we have approached Pfizer Healthcare Private Limited manager, sir, and they have happily agreed for this industrial expert talk. So they have introduced Mr. Natarajan Vijay Kumar amidst us. He will be delivering this online talk about pattern matching and anomaly detection from the industry's perspective. So before I give this session, I am delighted to introduce our esteemed guest speaker for today, Mr. Natarajan Vijay Kumar, who brings a wealth of experience and expertise in the field of data science. So he currently serves as the statistical data sciences lead at Pfizer, where he leads a dynamic team that utilizes advanced data analytics and machine learning to drive uh, some critical decision making in the pharmaceutical industry. So his journey in data science, it spans across multiple industries. So he worked at Caterpillar with vast amounts of structured and unstructured data, uh, which provides strategic insights for the business decisions. So his profound knowledge of data analytics and machine learning that has been instrumental in solving real world problems. So Mr. Vijay Kumar holds a bachelor's degree in electronics and communication from Anna University and an MBA in marketing and analytics from the MIT Trichy. So today he will be sharing his insights into the transformative power of data science, particularly uh, in the areas of pattern matching and anomaly detection. So on behalf of our division, on behalf of our HOD, and on behalf of you all, I welcome Mr. Natarajan Vijay Kumar. Please join me in welcoming Mr. Natarajan Vijay Kumar. So thank you for joining us. Now you can take over, sir. Thank you. Sir, your mic is muted, sir. Sorry.
Oh, thank you so much for the wonderful introduction. Yeah, so like are you able to see my screen?
Yes, sir.
Yeah, so today I'll mostly be speaking in terms of like what is being currently done in the industry and how exactly we are even utilizing the pattern matching and even the anomaly detection. So I've even seen through some of the courses that you are going through, and I do understand that you have certain theoretical knowledge. And I just want to give you a glimpse into how even these kind of different techniques are being utilized in the industry and what is the scope of them, and then why you should even care about these kind of techniques is where I hope that I'll be able to shine a bit of a light in this perspective. So with that said, I'll probably go into the session. So I'll probably like have about like 30 to 30, 20 to 30, 25 to 30 minutes with respect to the content. And then we can probably have Q&A at the later session. All right then. So hope everything is good till now. So then with that said, any questions or any queries, or do we get started, Martin?
Sir, straight away we will start, sir. And I request the students to clearly listen to the session. At the end of the session, you will be allowed for a Q&A session. So you can make use of that Q&A. So sir is eager to answer all your queries. So, but before that, I request all of you to keenly listen to the content what he is sharing with us.
All right, thank you, Martin. So with that said, I will probably go delve right away into the pattern matching and the anomaly detection. So primarily, I'll probably have this as two session. So first we'll look into pattern matching and what are some of the things we are doing specifically with respect to the industry. And then we'll look into an anomaly reduction so that you'll also have an understanding of like how it is even playing a role in the or playing some sort of role within the industry itself. So with that said, we'll just go into pattern matching. So since you already have it in a syllabus, I'll probably just give a brief overview. So like it's nothing but like identifying the patterns. So for example, like if we have say, for example, if we have classes being started at 10 o'clock at every day, then you know by next week also you will have classes start at 10 o'clock every day. So you do identify the patterns among yourself. So based upon the different criteria which is happening. So in the broad perspective, that's what a pattern matching is all about. So when we look into the data perspective, we are actually utilizing this in a lot of fields. So it's not just with respect to say the computation or even some of the data analysis, even healthcare also it is being utilized. So one famous example would be the pattern matching of an email address. So we do know like what will be the pattern matching of a specific email address. That is, it will be starting with the email ID, and then after that you will have the @ symbol, which will anyway be a common pattern among all sort of email address, be it whatever domain it be it Rediff, Gmail, Outlook, whatever the domain is. So this is sort of like the regular pattern which we know and which we're even accustomed to. So that is how even this pattern matching is even useful in terms of validating different kind of elements and also trying to see like how they can be utilized. Even in NLP also pattern matching is utilized very extensively, where we have something called as even regular expression. So that is also being utilized across the industry if you're looking into text analytics specifically. So that's where even the pattern matching sits in a place. So that's about a very brief introduction about pattern matching. And I know that pattern matching is in itself is a very vast topic where we have like multiple layers within the pattern matching and different types of pattern matching are also available. But in this session, I just want to give a glimpse of into like how even we are utilizing it in medicine and how even Pfizer as a healthcare company, how we are even trying to make use of these kind of different kind of techniques. So Pfizer is basically a healthcare company, and if we look into the medicine in and itself, like pattern matching is very extensively utilized. I have listed some of the main ways in which you can utilize. But for example, you can even take the COVID case, right? Like I hope that the COVID which has happened. So we do know like what is the pattern in which we have to identify a person has actually got COVID. So we see like whether he's having a fever, whether he's having a continuous coughing, and whether is he feeling weakening of muscles. So based upon that, we try to say like whether this person should be even taking a COVID test, whether he's actually having COVID or not. So that's how even we utilize in healthcare. And in a way like healthcare, all kind of diagnosis is basically a pattern matching, because like if you see like even the vaccines we are giving, right? So vaccines, we say like what are the different intervals in which we have to give, and then on which age which vaccine should be given. So these are all these kind of different things came up by identifying the pattern. And they even give up like even like different kind of warnings, or even different kind of like they'll say like what you should do and what you shouldn't do. Suppose if you take a medicine, what are the whether you should have light food, and if you have fever and if you take medicine, then you need to take consume less amount of food. So these kind of insights were even coming up within medical profession using pattern matching only. And again, like even if you see within Pfizer, we are pretty much well known for much of the vaccines, and vaccine actually like pretty heavily relies on the pattern matching, where we try to see like how it is interacting with the particular disease or virus, or how is it actually helping the person. So these kind of different kind of analysis is being done extensively by utilizing pattern matching. So that's how very relevant it is. And even in some of the broad therapeutic areas, or what we call as say like so therapeutic areas is basically like whether it is oncology. So those kind of different kind of streams we have. So there also it is being very highly utilized. And even if you see in the latest trends of AI, where we have like LLMs and Chat GPT, so with the advent of these kind of different AI models also coming up, again like it is being utilized. We do have developed like something called as knowledge graphs. So again, this is very prevalent in the other industries, but in healthcare also it is slowly picking up, where we even utilize fuzzy knowledge to make identify the different patterns, or how we can even make in terms of like how the pattern can be even analyzed. So that is one of so pattern matching is so the key takeaway over here is that like pattern matching is very relevant to medicine. and then it is being used extensively in healthcare to identify different diseases, diagnosis, and also even treatments. So all these different facets within healthcare heavily relies on pattern matching. So that is one way in which even the relevance in medicine is very relevant over here. And if we, so these are some of the primary ways in which even the pattern matching is being utilized. And now we can even take a specific use case of how this pattern matching even helps into play. So we do have like the different kind of like so it's heavy on, it's again like we can look into medical images, where again we have like different kind of medical images. We have like MRI, CT scan, and if you went even for any sort of health checkup, you would have known you'll have X-rays, MRI, CT scans. So we have like a lot of images being processed out there. And again like the report does not just like that get actually like generated. So they go through the different patterns within the particular MRIs or the given images to make the diagnosis of the same. So they will be having a specific pattern in mind to identify whether any sort of like relevance is present or not. So one such useful information is the skin cancer. So in skin cancer or in dermatology field, we do have like different kind of skin lesions will be coming up. So skin lesion is nothing but like in the skin you will suddenly have some sort of like discoloration, or you will have some sort of like what is it like and sort of like a very black kind of mark. So you have different kind of pigmentation happening within your skin. So these kind of skin lesions also we will be trying to see like what is the pattern which is coming up. And this is a very extensive process, so it's not like just one person takes it and then he analyzes and then he comes up with a solution. It's not like that. So again like the individuals I'm talking about have almost like 30 years of like academic experience, and they have at least like 5 to 10 years of like industry experience. So they are all well known renowned doctors, so they do take the steps in terms of identifying those different patterns, and they just don't do only through manual method. So within the medicine industry also we have like much more advanced pattern reduction, where we have techniques called as like histopathology, or we have something called as in vivo confocal microscopy. So like what does this mean? So histopathology is nothing but like trying to see the tissues themselves, not just the lesions, but trying to get the tissues themselves and then trying to see whether anything is mismatching, or if you are seeing something very different. So those kind of different kind of techniques are also being utilized. And we also do a lot of follow-up examination over here. So even if you go to the doctor, even for a simple case of fever, the doctor would say like maybe come after 3 days or 1 week. So you can see like for a case like skin cancer, that will be like a regular kind of follow-up being happening. So based upon these different follow-ups only, they will even classify the skin lesions, so that they will be able to know like how we can even treat the particular person and whether any treatment is needed or not. So these kind of different kind of methodology goes into the pattern matching. So it's not just about few of the techniques, or even like few of the like utilizing some techniques are also, or even some sort of like machine learning algorithms is not just being utilized. It's a very intensive process where they make sure that everything is right, and then we are able to understand the ground truth accordingly. So that's how the even the medicine industry is present, because like regulation comes plays a major role when you're looking into specifically the same some sort of like diagnosis with respect to cancer or even some other disease also. So that's where even these kind of different techniques go into place in order to identify whether any sort of pattern we have to look out for. So this is a very important way in which we even classify them. And based upon this, again, like we have identified different kind of skin patterns are also coming up over here. Like so, we have like a lot of skin lesions are coming up based upon the discoveries being done by the experts in this particular field. So we have we have like the melanchotic nevi, we have like melanoma, we have like basal cell carcinoma. So we have like multiple different kind of classifications being happened with the specific patterns. So it is very regressive, and then it's even like very thorough in terms of like identifying what is the pattern we are seeing, and then whether we have to do any treatment or whether we have to do any sort of like follow-up. So all those different kind of things are also being done through the pattern matching analysis over here. So this is very important, and this is also playing a very crucial role in terms of like making sure that the treatment or any sort of diagnosis being happening any place within the healthcare is actually having the ground truth in place. So this is a simple example in terms of like how a pattern matching is being utilized in the real world scenario in the medicine field. So again, like this might seem a little bit more very what is it, like very intensive and very manual, but that's again like again with respect to even the AI field also, this is actually creating a lot of scope again, like as we see in the upcoming slide. So now we have identified these different kind of patterns, right? So for any sort of like new classification of any sort of like patterns might be very difficult with the AI. But if you already have a pattern which is already we have been identified, then AI and even like ML models are also being currently utilized for pattern matching. So for existing known patterns, the AI model is being currently utilized very exhaustively, because like if you take a doctor's time, it takes like a lot of time for them to do any sort of analysis and do any sort of like pattern matching. They take a lot of time. So it's not very easy, and you would also be hearing about some of the wait times in the developed world, where they wait for like months, or even sometimes years if you're looking for specific experts. And even in India, if you want to look into like say specific experts, we have to wait for a considerable amount of time. So that's where even the AI model can come into place, where we can use these kind of different techniques available, and we can even help the healthcare professionals to make informed decisions at a very fast rate. So that's where even the AI model is being utilized for pattern matching. So this is again a continuation of the previous one. So where we have the different kind of skin lesions, right? And even the healthcare community is also helping by giving out these different images. So we have something called as ham 10,000. So this is a open source data set released by Harvard. So this contains almost like close to around like 10,000 different skin lesion image, which with all the classification based upon the feedback given by the experts. So this data set is available for open source. And this is also very popular among the data science community, where even like multiple classifications techniques have also been utilized on top of that, such as transformers or convolution neural networks. So different kind of classification algorithm have also been utilized. And this is one such example where we can even use like visual LLMs. So where we use the different visual LLMs present in order to make sure that we are able to identify the pattern and then see like what is the different kind of lesions we are getting over here. So this is a very current example where you can see like the pattern matching which has been done previously, how it is being utilized within the current AI method or AI models in order to do the classification. So this is a pretty much, I hope this gives you a very complete picture in terms of like how pattern matching even helps in the healthcare industry. Again, like so this is just one simple example, but again we have like n number of applications available, be it the breast cancer diagnosis or even diabetes, which is again a very serious problem when we consider within India, where we have a lot of people with diabetes. So that we can even use the AI to identify whether any sort of like genetic profiles, and then see like whether we can tailor the specific treatments or not. And even within COVID-19 also we have utilized a lot. So within the context of India, we have something called as Arogya Setu. So that again utilized the pattern matching in order to identify different zones, whether they were like whether the zone is a safe one, or whether we have to be very careful with the specific zone. So again, like pattern matching was utilized. Of course, like multiple other models also go into place, but pattern matching is one of the key elements or key algorithms being utilized over here. So with this, I hope that you would have had a clear understanding of like how pattern matching is even being utilized in the modern medicine, and how even going forward, when we are going to much more into personalized medicine, we will be seeing a lot of use cases for pattern matching. Although it won't be just in a specific format, we have to utilize multiple different kind of models along with pattern matching. But of course, this is pretty much like the future where we are even seeing like chatbots even coming up with AI healthcare. Again, they go through certain pattern matching. So this is how even like the evolution of pattern matching is happening within the healthcare industry, and how we are even utilizing these kind of different techniques to make sure that we are utilizing the correct techniques and then the methodologies to give the healthcare and which is accessible to everyone. So this is a brief introduction or a brief overview of how the pattern match is being utilized over here. So again, I'll give you some of the. So I think I'll probably share the slides with you. You can even look into the references to understand like how even these kind of different kind of algorithms are present, so that you'll also get an idea of the same. So with that, I'll go into the next part of this particular session, just anomaly detection. So anomaly detection might looks similar to pattern matching, but it's a little bit different. You could say it's sort of like a subset of pattern matching, but of course it comes in itself as a separate field. So like if you're looking to anomaly detection, so pattern matching is like identifying the specific pattern, like how is it coming up, like in the weather, whether today it will be rainy or sunny. So those kind of pattern is happening. But anomaly detection specifically looks into outliers. So yeah, we can see like, so even if we take the example of weather, where we see like whether it's cloudy or sunny, but sometimes you will see like unusual patterns, like having like very high torrential rains, or you will see a lot of wind activity. So if these kind of very high level of outliers coming up, that's where the anomaly detection comes up. So this is also like very critical when we are looking into specifically for healthcare, because majority of the high impact diseases use anomaly detection, be it cancer, where a lot of anomaly detection is being utilized for different kinds of cancer, and we are also utilizing it for different kind of like so even in diabetes also we utilize. So I try to understand like whether any sort of deviation is happening. So this also comes into the first set of like understanding whether we have to look into a particular person or not. So a simple example would be like if you take a blood pressure, we do have a normal range. So if you're recording something for a person which is above the normal parameters, then we do additional test. So that's where even the anomaly detection comes into play. So we try to identify whether there's an anomaly present or not in order to do further examination. So again, anomaly detection is a very useful technique in terms of like how we have to even utilize it. And in the context of medicine, it's again like very relevant. So as I mentioned, like so again, these are some of the relevance in medicine. But again, like as I mentioned, like in the blood pressure case, so even not just within blood pressure, even for diabetics, right? We do take the sugar content and see whether it is within a specific range. If it is abnormal, then we try to see like whether we have to do further test, and then we even make certain diagnosis based upon the kind of results we are getting over here. And we also do this kind of activities even within ICU, so like intensive care units. We do a regular monitoring of the person to make sure that everything is stable, and then the person is not in distress. So those kind of different mechanisms are also goes into play for specifically for anomaly detection. And we also utilize it specifically for even genomic research, where we even try to isolate like which kind of genes is causing which kind of disease. Again, like this again goes through a sort of anomaly detection. And it's not just in the medicine or even the diagnostic field anomaly detection is replaced, it's also used in quality control. So specifically with Pfizer, we do a lot of development of vaccines, and we try to see whether the vaccines we are developing, whether it is conforming to a specific standards, and then whether we also do a lot of techniques in terms of identifying, or even like we even do a lot of scanning and then seeing like whether the medicine is in the appropriate range. And then based upon that also we try to see like whether is there any sort of like anomaly present within the medicine. So even in quality control also it's being utilized within the medicine field. So that's how it's very relevant even in within the medicinal field. It might look very similar to pattern matching, but it in itself is a very vast field anomaly reduction, because even the abnormality, even within abnormality, there's a lot of variation. So like if you take a blood pressure, like it could for some person it could be like a variation of like 30%, but for another person it could be a variation of 50%. So depending upon the variation itself, like the treatment will vary, the diagnosis will vary, and the kind of treatment that we have to give again will vary. And if the again like if it is a low blood pressure, then the approach will be completely different. So yeah, so that's why even we have a separate field called as anomaly detection, and not just clubbed together within pattern matching. So, for example, like even within anomaly detection, we do have like multiple different kind of techniques available. So we do have something called as the isolation forest, and then one class SVM, local outlier factor. So yeah, so as I mentioned, like this we branched out of pattern matching. So again, why it branched out is because when we try to see the patterns, we are seeing a lot of anomaly, and we even devise techniques for the same, so that we are able to get those different anomalies in a much more like what to say, like in a much more robust manner. So that's why even these kind of different techniques were also even developed. And we are also having some of the traditional methods, like a box plot is a very simple technique which is being utilized across industry as a simple standard procedure to see whether any sort of anomaly is present. And again, like scattered plot is again a graphical representation. And we also have statistical method like chi-square, or even like z-score or Grubstate is also being utilized to identify any sort of anomaly present within a particular data points. So again, like as we have seen some of the relevance in medicine and also some of the types of different types of the anomaly present, we can even see like how it is even being utilized over here. So initially we saw for the skin cancer, now we can look into the breast cancer. Like so breast cancer again, like there are like so we have like stage one, so we have different kind of stages of breast cancer. So initially within the dermatology, we had different types of skin lesions available. So that's why we even went with pattern matching to see whether the particular pattern is very close to a specific pattern or not. But here we are trying to see like specifically only for breast cancer. So like here we have like stage one breast cancer and we have like multiple stages. But here we are in this specific example, we are just looking into a specific stage one breast cancer because like if patients are readily identified within stage one cancer, then it is much more easier for them to get recovered, and also it's much more effective treatment also can be given over here. So again, we are utilizing a very open source data set available over here. So if you guys even have some interest, you can even like Google a lot of medicinal data sets are actually available as open source, and even the data science community is also very much like they are very open, and then they are also very active in these kind of different data sets to identify like what's happening even with the particular data over here. So this data contains only like some of the demographic details and some key medical information related to the specific stage one cancer, and not just stage one cancer, but different kind of cancers methods we are seeing. And again, like we have even a flow in terms of place, in terms of identifying how we even go into the classification of the breast cancer over there. So within the industry, we do follow a set of process available. So with the data, we just like the don't start applying the ML techniques. We start with understanding the data profile first, and then see if any sort of missing values are present or if any duplicate values are present. So all those kind of data profiling is being done, and once the profiling is done, we can classify the data whether it's categorical or numerical, and then we standardize and normalize the data by using different techniques like one-hot encoding or normalization techniques. So this in itself will almost consume about like 60 to 70% of the time, and then only we will be starting with a model fitting where we utilize different kind of model to understand how the anomaly is being present, and then how we can even identify the anomaly, how accurate it is. So this will again, there will be a lot of fine tuning going over here, and then finally we'll be evaluating using different metrics like be it precision, recall, accuracy. So different kind of evaluation also goes into this particular methodology over here. And if we utilize this data, we can even like use multiple techniques in order to identify like what is the results we are getting over here. So for this, we are utilizing something called as confusion matrix, which is very famous in terms of understanding the evaluation of how the particular model is performing. So we can see like the different kind of performance happening within different kind of ML techniques itself. So again, like you can even like customize the ML algorithms. It's not necessary that you have to use only like one specific technique. We have multiple techniques available within the industry in itself, and depending upon your use case, you have to pick and choose like which kind of model is needed. So that's a very valuable asset. So just knowing the model is not enough. You need to understand like which kind of model needs to be utilized over here. So for example, if you're looking for only precision, which is how accurately it is predicting, then we'd probably go with something called as one class SVM, where we are seeing a lot of positives is getting predicted accurately, and there is less number of false negatives. But if you see the other models, there is a lot of false positives and false negatives coming into play. So that could be a bit of a red flag if you're looking only for a precision. But if you're looking for recall, then we might even go with isolation forest or even local outlier factor, because they're able to predict the model in a much more easier manner. So again, like there are different ways in which you can identify anomaly, but then and again, you need to again come up with the rationale behind why you have to choose a specific model. So that's how even these kind of different techniques are even chosen over here. But here we are looking specifically for precision. So here we can say like one class SVM is doing much more better. So with that said, like again, like anomaly, although it might look like a subset of pattern matching, it in itself is a vast field where we have like multiple techniques available, and it's being utilized in the modern medicine very exhaustively in order to identify what are the different kind of anomalies we are seeing over here, and how we need to treat them, and what are the different diagnoses we have to give over here. And we also have to do and again, like here there could not be a lot of pre-labeled anomalies, might not be there. So for example, like in the previous one where we saw pattern matching, we already had some label available, but in these techniques it might not be the case, because we're just only seeing anomaly which is far off from the range. So this again is utilized in the very continuous monitoring systems is where we utilize even anomalies. So we even utilize in the like what's like in the electricity generation also it will being utilized, and even in nuclear power plants also anomalies are utilized very extensively. So again, like that's not a lot of pre-labeling, so it's a lot of like it can be utilized for a continuous data set much more exhaustively. And also it is even being utilized within clinical data. So be it the drug discovery or the submission of the records, so whatever it may be, the anomaly reduction is being utilized again like very exhaustively to make sure that we are not actually we're not actually misclassifying something, and then we are able to understand like what is the specific anomaly and what's the rationale behind it. So that's why even these techniques are also being utilized. So this is just again a very overview of how the anomaly detection is being utilized, and how it is a little bit different from pattern matching, and how exhaustively it's being utilized within the field of medicine. So with that, I hope like I've given you a brief overview of like how it is even being utilized, and then how you can even like explore different kind of data sets available, specifically even within the field of healthcare, where we are seeing a lot of innovations coming up. So it's not just in tech field where we are seeing these kind of different kind of methodologies being applied. Even within the field of healthcare also, we have a lot of these techniques being applied over in nowadays. And even the healthcare industry also very open to it, because we also have to accommodate towards the trends which is happening in the field right now. Again, I will give you some of the references in terms of like you can even take a look into this when you do have some time. And with that said, so yeah, so that's with respect to my contents. Yeah, so with that said, I'll probably open up to questions. Anything else? So yeah, so yeah, over to you, Martin.
Uh, Thank you so much, sir. Thank you for the very detailed presentation. Now it's open for questions. So I invite the students to open up for any queries. So sir is here to hear your queries. Yeah, anyone is opening up? Okay, sir, on behalf of the students, I would like to have maybe one point to be clarified from the industry's perspective view, sir. So you were talking about all the, this real-time data sets, especially the various diseases. So you were talking about the skin cancer. So when I talk about skin cancer, the pattern matching is related to the data set that you are, that we are taking it. So all the images that you have, so you will be performing the process based on the images that you have, sir.
Yeah, so in the images, again, like I didn't go in detail in terms of like how we are doing it over here. So if you even see into the specific techniques, what I've utilized. So we even like go through some of the different techniques. Like we won't just like that give the image itself. The image again, like sometimes it could be of like lower resolution or higher resolution. So, but we would prefer an image which is of a higher resolution, so where we even utilize like GAN techniques, and then we even augment the data, and then we normalize it again. So once the normalization is done, then we will convert all the images into arrays. So the images will not be just like that given over here. It will be normalized, and then it will be transformed into arrays, and on that only we will do the processing.
All right, sir. Sir, actually, your industry is actually producing the medicines, right, sir, at the outset?
Yes, yes.
Okay, sir. So in what way, the AI and ML concepts will lead us to, to produce medicines from the industry's perspective?
So medicines, like if you're looking into the specific medicine, like we can see like something, there's a new upcoming field called as indication expansion. So what does that mean? Like, so if you take a specific drug, right? So for any drug being developed, we have to spend like billions of dollars, and it will take like at least like half a decade or even even more than a decade for some of the medicines, for any of the drugs we are developing. And but of course COVID pretty much changed that, where we were even able to develop a drug within like 8 months, even 6 months also in some cases. But developing any sort of new drug is very expensive. So that's where even with use of AI and ML, we came up with a concept called as the indication expansion. So what does that mean is that like we utilize the drug which is already discovered for other purposes. So a very famous example is Viagra, where it was initially used for the vascular dilation, where we were actually trying to increase the blood flow within the heart. But of course it was also utilized for even like the sexual impotence, also for the erectile dysfunction also it was being utilized. So that's sort of like an indication expansion. So that's where we are even seeing the AI field also being utilized very extensively. It might not directly help in the discovery of drugs, so even they are also very utilizing it and even assisting them. But we are very much highly involved in this indication expansion, where we are trying to identify other use cases for the already discovered drugs. So this is just a glimpse of how we are even we are being even used in the specific drug discovery.
Sir, thank you so much, sir. Finally, sir, our students are AI/ML students. Sir. Primarily, they are focusing on AI and ML concepts. So, as you are an industry expert, could you please give the guidance that is the scope of this AI and ML after they complete their, their studies, especially in the industry's perspective?
So from an industry perspective, we are actually like going towards the AML. So yeah, there's a lot of scope in the future in terms of like the use cases for different AML techniques. There's a lot of future actually being coming up over here. And even within Pfizer, like 5 years back, we didn't have a very robust AI on A and ML team, but now we have like almost like more than 20 plus members working on A and ML. So that's how the industry is even developing. But of course you do have to keep up with the trends in terms of understanding like what is the idea behind the A&ML. It's just not enough knowing the A&ML. You have to have a brief understanding of how it can even be utilized, what is the use case for it, how the business will even like be profitable because of using them. So once you have this kind of like scope or understanding of how this can even be implemented and how it can be useful for the business, the scope is like limitless. You have like n number of companies, not just within healthcare Pfizer. You have tech, you have retail, you have energy. So like the A&ML is pretty much touching all different fields, and it's actually being even utilized right now. So yeah, so it's pretty much like a massive revolution is happening. So like yeah, so initially data was considered as the new oil. Now again, like the AI will be considered as the new oil. So that's how it's even getting developed nowadays. So yes, it has a lot of future.
Thank you so much, sir, for your valuable time. Share your experience, especially in the area of pattern matching and anomaly detection from the industry's perspective. So, at the outset, on behalf of our division, on behalf of our HOD, our students, I would like to thank you, sir, for your valuable time. So I would like to collaborate this in future as well. So in this time, I would like to thank Mr. Alex also, so who has been an initiative when I contacted him. So he has rightly directed me towards you. So I hope students would have enjoyed this session. So thank you so much, sir. In future also we would be collaborating with you. So I hope it goes well. Thank you so much, sir.
Thank you, Martin. Thank you very much.
So thank you all students. So I will just post a feedback form in the comment section. So please take that feedback form and complete it, submit it immediately. So thank you all. Thank you, Natarajan sir, once again.
Yeah, thank you. Thank you so much. Thank you all.
Dear students, I have already I have posted this form link, so you can just take that and give your feedback.